Let us try to understand what are pseudoprimes. In order to understand pseudoprime, let's recall Fermat's little theorem. If p is a prime and a is an integer relatively prime to p, then a to the power p minus 1 is congruent to 1 mod p. How about the converse of this theorem? Does there exist an integer n such that 2 to the power n minus 1 is congruent to 1 mod n and n is composite? So, Fermat's theorem says a to the power p minus 1 is congruent to 1 mod p. That is a property of prime, but there exists an integer n such that 2 to the power n minus 1 is congruent to 1 mod n and n is composite. Such numbers are called pseudoprimes. So pseudoprimes are simply composite number n such that 2 to the power n minus 1 is congruent to 1 mod n. In other words, converse of Fermat's theorem is not true. Let us prove that 341 is a pseudoprime. We will use Fermat's theorem to prove it. By Fermat's little theorem, 2 to the power 30 is congruent to 1 mod 31. As 31 is a prime, so 2 to the power 31 minus 1 is congruent to 1 mod 31. Now let's raise it to the power, we want 340, so let's raise it to the power 10 or 11. So let's raise it to the power 10. 2 to the power 30 to the power 10 is congruent to 1 to the power 10. That gives us 2 to the power, let's raise it to the power 11. 2 to the power 330 is congruent to 1 mod 31. But somehow we want 340, so let's multiply both sides by 2 to the power 10. We multiply both sides by 2 to the power 10. So we'll get 340. We multiply both sides by 2 to the power 10. Rest of the expression we copy as it is. 2 to the power 330 times 2 to the power 10 is congruent to 2 to the power 10 times 1 mod 31. Okay, 330 and 2 to the power 330 and 2 to the power 10, that gives us 2 to the power 340, which is congruent to 2 to the power 10, but 2 to the power 10 is 2 to the power 5 whole thing square, and 2 to the power 5 is 32. 32 whole thing square mod 31. But we know that 32 is congruent to 1, so 2 to the power 340 is congruent to 1 square mod 31, and 1 square is again 1. Let's do similar thing with modulo 11. Once again by Fermat's little theorem, 2 to the power 10 is congruent to 1 mod 11. Now we want 340, so we raise it to the power 34. 2 to the power 10 is congruent to 1 mod 11. We raise it to the power 34. We raise it to the power 34. So good. So we get 2 to the power 340 is congruent to 1 mod 11. But you see that 11 and 31, they are all relatively, they are both prime, they are different prime. So we can say that 31 divide 2 to the power 340 minus 1 and 11 divide 2 to the power 340 minus 1. So it must happen that 2 to the power 340 minus 1 or is congruent to 0 mod 31 times 11, that is 341. And we are done.